ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Now let's continue with phloem transport, students. Phloem transport is very important. Bidirectional movement of phloem we have discussed for the last class. So let us continue with that. So when we take the phloem transport, what we have discussed is very important. What is the thing we have discussed? Itself is called mass flow or itself is called as bulk flow. Bulk flow hypothesis. So we have studied what is called mass flow, or what we studied is bulk flow, or this is also called as what? En masse. This is also called as what? En masse. So if you look at in this, what is the first step we need to talk about? So there is a loading of organic material. There is a loading of organic material. What is the first step in this? We study about loading of organic material. And what is the second step in this? We get it into, we call that one as unloading of organic material. Unloading of organic material, or itself we call food. Unloading of organic material, or itself called food material, right? So when we make the loading and unloading here, mainly what we need to talk about here, so we take the things like leaf as a source, root as a sink. What we have discussed? Leaf as a source, root as a sink. Now, so in this loading of organic material means, let us talk about this. As I said, leaf is the one acting as a source. Source for what? Source for sucrose, right? It is acting as a source for sucrose. So when you take the sucrose into this, now when you take the leaf in this case, what happens here? From the leaf, where it is entering here? Sieve tube elements. Sieve tube element of phloem. Within the leaf, where it is present? It is present in the sieve tube element of the phloem. So when you talk about the sieve tube element of the phloem, from the mesophyll cell, leaf means from where it is going to begin? It's going to begin from mesophyll cells. It's going to begin from mesophyll cells. So when talk about mesophyll cells, from this it's coming, also enters into sieve tube element of stem. It enters into sieve tube element of the stem by active transport, or itself is called as by active transport, or itself is referred as what? Symplast. Very important. What we are talking, from where to where we are discussing? From the mesophyll cells of the leaf into vein. Vein contain what? Sieve tube element of the phloem, and that in case of leaf itself we find sieve tube element of the phloem. That means leaf sieve tube element to coming to sieve tube element of the stem. But before to that sieve tube element of the stem, better you can write that directly it will not enter. It will enter to what? It will enter into what is called companion cells. Enters into what? Companion cells. Where companion cells are present? Companion cells are present in the stem. That means we are discussing three things. Nothing here. What we are discussing in phloem transport, we are discussing three things. What are the three things here? We say sieve tube element of leaf. From where to where we are discussing? It's going to begin with a sieve tube element of leaf to a sieve tube element of stem Entering into where? Sieve tube element of the stem. From there it enters into sieve tube element of root. Sieve tube element of root. What are the three parts we are discussing here? Leaf is nothing but the one acting as a source here, and root is the one acting as a sink. Already, right? Already we have discussed. Alright. So here you can see leaf is the one mesophyll cell fully loaded with the sucrose. That's why we write here as mesophyll cells are fully loaded, it's called loading. It's called as what? Loading. Why it's loaded? Because mesophyll cells of the leaf are fully filled with sucrose. So it acts as a source, obviously, right? From there it is entering into what? Sieve tube element of the stem. From there it is entering into what? Sieve tube element of the root. Now in this case, root is acting as a sink. That means food material, translocation of food happening from where to where? From the leaf to root. Happening from where to where? From the leaf to where? So if you take, this is a plant, this is a leaf, so this is a stem and this is the root. When you take, this is the root. So stem is bringing the large quantity of the food. After coming here, what is happening? Stem is giving the total food to root. So what is happening here is unloading. What is happening here? It is unloading. First one is loading and second one we call it as unloading. Loading means mesophyll cells are fully loaded with the food in the leaf and they give the food to the root. Root act as a sink. Where what happens from the stem? Stem is sending the total load into the root. So what is happening here is unloading. So here, what is the directional movement we are discussing here? From the leaf, food is coming to stem and from the stem it's going to the root. So we are talking here, what we are discussing here? We are discussing in this case, we are discussing a downward directional movement. What are we discussing? Downward directional movement of food. Downward directional movement of food. It's going from where to where? Downward directional movement of food. That means from the leaf food is coming down to the stem. From there where it is going? It's going to the root. Right? So this is called downward direction. Then where is upward direction? I told you for the last class, I will show you very in detail about this. So if you take, this is the stem part. Now if you look at, in this case if you look at, this is nothing but in this case if you look at, now sometimes root also contain the food or the leaf at the basal part. At that time it goes in upward direction. So this is you take as downward direction. This you take it as upward direction. Let us take this as upward direction. This is coming as downward direction. This is going as upward direction. How upward direction of food is going? By only one thing that is very important. We already have discussed that. What is that? Which we call it as transpiration pull. What is the thing we have discussed? It's called as transpiration pull. What is transpiration pull in this case? Here the food is going from where to where? Basal part of the leaf to upper part of the leaf or from the root to leaf. We will get back to the last point. Last point we say that source and sink are variable. That we will discuss in the last point. Means in this case downward direction if you take, leaf is a source, root is a sink. Sometimes what happen? Basal leaf this act as a source, upper young leaf may act as a sink. That means movement is happening from where to where? From source to sink. Who is sending is called source, the one who is receiving is called sink. Does you think always leaf act as a source and this act as a sink? No, definitely no. That we will discuss as the last point. But here try to understand, in the phloem when you talk about, remember it is always bidirectional. Why do I say so many times it is bidirectional and bidirectional? Why? Because we have to remember in case of xylem it is unidirectional. Always the statement what you have to remember is in xylem it is always unidirectional, but in phloem, coming to phloem, it is a bidirectional. See here, leaf, food is coming down to stem to root, this is downward direction, and from the lower base of the leaf or from the root, food is going in upward direction. How food is going in upward direction means, try to remember by transpiration pull. We already have discussed this. Whenever stomata loses water here, all cells becomes empty. At a time they apply the pressure on the lower cells, so that lower cells will give water. At a time so much of pressure is applied to take the water, minerals and food in upward direction, and that itself is called transpiration pull. Remember, transpiration pull not only causes upward movement of water and minerals and also food materials. Organic food materials are translocated in upward direction. Translocated means longer distance. Food materials go along with water and minerals in upward direction. It is basically by transpiration pull. Then the question arises, how bidirectional movement, from leaf how it is coming down, from the leaf how it is coming down, downward directional movement how it happens, because there is no transpiration pull downward direction. So how it happens, for that the clarity is being given by a mass flow hypothesis or what we call a bulk flow hypothesis. That is why it is very, very important. Sometimes we have a questions even from mass flow or bulk flow hypothesis. So what we are discussing in this case is nothing but a downward directional movement of the food, not the upward direction. So we talk about, generally the question arises in the scientist mind, how downward direction movement happens, because upward movement is taken care by transpiration pull. Then when he thought that how it happens, then he discovered what is called mass flow or bulk flow hypothesis. The conclusion is mass flow or bulk flow hypothesis explains about downward directional movement of food. That means again from where to where. So first step is called loading. Loading happens in sieve tube element of the phloem of the leaf. So leaf in this case act as a source, then enters into sieve tube element of the stem, then unloading happens from the stem to root, that is finally it reaches to sieve tube element of the root. So here loading is happening and in this case unloading is happening. How it happens, we will write step by step again, imagining the last class diagram, keeping in the mind the last class diagram from leaf to stem and to root. Keeping in view of last class diagram, see carefully, again read, go through once the last class video. With that we are going to write the steps for mass flow or bulk flow hypothesis. So in this case leaf act as a source and root act as a sink. Now let us come back to this part. We are writing step by step how loading happens and how unloading happens. Right. So here where to where the movement is happening, from the leaf, in leaf sieve tube element of the phloem, right, from there enters into stem. How it occurs means by active transport or by, we call this one as by symplast, right, enters into companion cells in the stem and from the companion cells enters into sieve tube element. Remember, very, very important, what we have to remember, companion cells are nucleated. So they develop pressure gradient, in sieve tube elements, sieve tube element of phloem we say. And sieve tube element, remember the sieve tube element is enucleated. sieve tube element is enucleated, right. So, companion cells develops pressure gradient in sieve tube element. Slowly the food enters into sieve tube element of the phloem. So, here sometimes they will give the question that from here to companion or sieve tube, but directly the question will come from here to here, from the sieve tube element of the leaf to sieve tube element of the stem. At that time also you have to write it is, or for this also the answer is active transport only. You have to remember and write active transport, or itself is called as symplast, or itself is called as what? Symplast. Okay. So, when we take the sieve tube element of the phloem, it enters into sieve tube element of the stem here. From there, when it it causes what? High sucrose concentration, or we say high solute concentration. When it causes high solute concentration here, then what happens? It will take water. It will take water. It will take water from where? It will take water from xylem. Actually, you can write down completely and go vertically down in your writing part. So, xylem is the one who is providing a water. So, this is giving water by what process here? Here by the process called as osmosis. Xylem is the one giving water. Here xylem is giving water. Water enters from where to where? Xylem to sieve tube element of the phloem by osmosis. Similarly, if you look at from the companion cells, the food enters into sieve tube element by what process here? Diffusion. Very, very important. This occurs by diffusion. Make sure that you write diffusion. Now, then within the sieve tube element, we are talking about within the sieve tube element, then increases turgor pressure, osmotic pressure increases. When osmotic pressure increases, let us continue writing down. I am writing here. Let us take to unloading of organic material. Into this you get it, or you stop writing there. So, this arrow mark, just make it as like this. From up to here you can write under loading. So, I will just continue from there. So, I am just continue from here to here. From here the step comes to what is called unloading of organic material. So, what happens in the sieve tube element of phloem? Where are we in the discussion about? We are in the discussion about the step. We are in the discussion about this. So, within this what is OP? Osmotic pressure. What is OP? Osmotic pressure. So, not only the osmotic pressure, it also causes turgor pressure. Turgor pressure increases, osmotic pressure also increases, where within the sieve tube element of the phloem, and it also creates what? High hydrostatic pressure. It creates high hydrostatic pressure. Then movement happens to low hydrostatic pressure. Low hydrostatic pressure. By what process here? By within the sieve tube element, the process is passive transport. The process is passive transport, or itself we call this as apoplast. Okay. So, we call this as passive transport, or itself is called as what? Apoplast. The movement is happening from high hydrostatic pressure to a low hydrostatic pressure. How the movement is happening from high to low here? By passive transport or apoplast. Where this total thing is happening? Total thing is happening within the sieve tube element of the phloem. Right. Now, it reaches to the lower part of the base, and again from here, after it reaches to the lower part of the base, again from here water goes back to xylem. Water is going back to xylem by osmosis, and remaining solute particles entering into a sieve tube element of phloem in root. So, This is what is called as second step, unloading. We call this as what? Unloading. Unloading of wood material. Remember, it also occurs by the process called as active transport. It occurs by the process called active transport, or itself is called as symplast. Guys, everything we discussed in the diagram, everything we are just putting in the steps, that is all. What we are doing here is we are writing in the form of a steps. Everything is clear in the diagram. Once if you understand the diagram, you yourself can make writing from where to where the food is moving, starting from the leaf which acting as a source to the root which is acting as a sink. You can write all the steps very in detail. Why we have written? Because to show where active transport is happening, to show where passive transport is happening, to show where osmosis is happening, where diffusion is happening, again where active transport is happening. So, here once the food is moving to the sieve tube element of the phloem within the root, here again the water goes back to the xylem. So, these are nothing but two important steps. One is nothing but loading of organic material, other one is nothing but unloading of organic material. I hope everything is clear here. I just tell you quickly revision let us do. So, in this mesophyll leaf act as a source, undergo photosynthesis, stores excess amount of the sucrose. Sucrose will enter into sieve tube element of the phloem within the leaf, within the vein. From there it comes to directly sieve tube element of the phloem through companion cells within the stem, and this occurs by what is called active transport or by symplast, active transport and symplast. Now, first it enters into nucleated companion cells. Companion cells helps in creating pressure gradient within the sieve tube element, that is by the process called diffusion. Then from the sieve tube element, the sieve tube elements are enucleated, then high solute concentration it reaches, and here with the water potential difference, what plays an important role is water potential gradient. Sometimes they will give you question, which processes are dependent on water potential gradient. Which processes are dependent on water potential gradient? Opening and closing of stomata also depends on water potential gradient. Phloem transport or sieve tube element also depends upon water potential gradient, right? Like that, even if you take translocation also depends upon water potential gradient. So, which processes depend on water potential gradient, which processes do not depend on water potential gradient, sometimes you have a chance of getting the question. So, here moving is from xylem is having higher water potential and phloem is having low water potential. So, its movement is happening from high to low, high to low. So, that is by osmosis. Then within the sieve tube element osmotic pressure increases and turgor pressure also increases. So, movement happens from high hydrostatic pressure to a low hydrostatic pressure. Within the sieve tube element what occurs is passive transport or apoplast. Then what occurs, it is called here unloading, and here by active transport symplast, sucrose enters into sieve tube element of phloem of the root. In this case root is acting as a sink and left out water again goes back by osmosis into xylem. So, that is unloading and this is loading. Now, let us see the conclusion part in these cases. What are the important conclusions from the mass flow or bulk flow hypothesis? Let us see that. So, in this mass flow or what we say bulk flow, there is a first thing, there is a exchange of materials happens between what and what? Exchange of materials happens between xylem and phloem. It happens between xylem as well as phloem. Okay. So, here exchange of materials which happens between xylem and phloem. So, that is the reason why, what is the conclusion we already have written for the other class. Xylem not only carries water and inorganic minerals, along with that it also carries inorganic minerals, it also carries organic materials, organic food, traces of organic food materials. Right, this is important. Similarly, we already have discussed the conclusion part. Phloem not only carries the food or organic compounds like sucrose and all that, sucrose including other sugars like galactose, right, also carries water, amino acids including plant growth regulators, or we call hormones, So, that means even it carries water. So, this is one conclusion part. Why? Because here we say exchange between xylem and phloem, phloem to xylem with the help of an experiment called osmometer. That itself is a beginning stage for the study of what we call bulk flow or mass flow. Second thing is loading and unloading. This is the most repeated question. So, you can take in the finally sometimes you have a chance of getting the question. Loading and unloading of what you call food materials or organic food in phloem transport. Remember, it happens both by active and active transport. Sometimes they will give you that options like active and symplast, both are correct because both occurs by loading and unloading, both occurs by active transport. Okay, even though we say it reaches to companion cells, from companion cells enters into sieve tube elements by diffusion, even we say that, but mostly in the phloem transport to the stem it occurs by loading. Unloading also happens with the help of active transport. Loading and unloading, both of them occurs by active and active transport. Simply you can write active transport, or sometimes they will give active and symplast. Right, this is one thing, very important thing. Now, apart from this, if you look at, there is another thing which we have to discuss, is nothing but source and sink are variable. Source and sink are variable. So, in mass flow, bulk flow, one very important aspect which we have to understand is source and sink are variable. When you take the source and sink are variable, what is the meaning of this? So, generally if you take what we have written, leaf act as a source and the root act as a sink, right? Leaf act as a source, root act as a sink, but always it may not happen. In some plants it varies depending upon the season, right? Sometimes what happens, for example, if you take, when you take deciduous forest, in deciduous forest case, what happens in spring season especially, suppose if you talk about in spring season, generally in spring season we say that suppose the plant have all leaves got fallen, and all leaves got fallen. So let us take this is a plant. At that time what happens, no leaves here, all leaves got fall off. At that time what happens, root has storage of food materials. So it has stored food materials or reserve food materials. So from the root, the stored food materials will translocated in upward direction, reaches here and lead to formation of young leaves. This food is supplied to the branches for the formation of young leaves. So you can write here for the formation of young leaves. At that time what happens, you know that new young leaves, new branches, new flowers, new leaves get formed in spring season. At that time the all branches or the all leaves are already got fallen off. At that time root is acting as, in this case what happened, root act as source here. Who is acting as a source here? Root acting as a source. The young leaves are acting as sink. So movement happens from root to leaf, or root acting as a source and the leaf acting as a sink. So we cannot conclude that leaf is always a source and root is always a sink. No. So that is why we say the conclusion is source and sink are variable. Leaf is always not a source, root is not always a sink, both are variable. Sometimes, for example, if you take deciduous forest, I repeat, listen, in spring season you know that already leaves will get fall off. Now only empty branches you will have. At that time root will already it stored some of the food materials. So whatever it stores from the stored food materials, it will supply the nutrients and minerals to the young leaves. The new growing young leaves will take the nutrients and formation of the leaves takes place here. So at that time what happens, root act as a source, and in this case what is happening, some cases like where root acting as a source and here the young leaves which are produced from this acting as a sink. So source and sink are variable, depends upon seasons, better you write down here are variable as they depend on and depends on season, depends on seasons, right. So this is also one of the important thing which we make sure we understand about what is called mass flow or what we call bulk flow. But major experimental support for the mass flow, bulk flow is nothing but, remember again we have to remember, one is nothing but girdling or we call ringing experiment. So this is what we have studied, and other one is nothing but osmometer experiment. Osmometer experiment. So with this we just have to understand what is called mass flow or bulk flow, right. Now this is what we have to study about mass flow or bulk flow. Now let us talk about mass flow and bulk flow. It is clearly understood now. Let us see some of the points. For example, let us come back to guttation. Let us write some note points. So if you see the guttation, what we have studied is a phenomena to understand what is called a root pressure. So we all know that root pressure is a positive hydrostatic pressure. Root pressure is a positive hydrostatic pressure. So when we take the positive hydrostatic pressure, the root pressure, now in what you have understood is nothing but, you know, in case of herbaceous plants, it happens in herbaceous plants. Why? Because 80 to 85% it contains water and only 10 to 15% it contains a dry organic matter, means dry weight. So, we discussed this already, it is spoken in terms of a dry weight. So, only 10 to 15% of dry weight means remaining 80 to 85% of water. Where it happens means most commonly we find in case of herbaceous plants like cucumber, colocasia, all the 345 genera we have discussed. Then when people saw that how it happens means the people have understood that. So, there is a loss of water on the surface of the leaf. So, what we have understood at the time, either we can say early in the morning or we say late in the night. Early in the morning or we say late in the night. What happens? The stomata get closed here because atmosphere has more humidity. Atmosphere having more humidity here. When atmosphere is having more humidity, stomata, whatever the water loses, it stays on the surface of the leaf. We already have understood this. Then what else you have to understand here? From where the loss of water is happening? Not only from the stomata, now in the leaf if you look at veins. When you take the veins, on the surface of the veins you find some minute openings, minute pores. On the surface of the leaf you find a minute pores. Minute pores means openings. Where? On the midrib or on the veins. Right. So, these are present on the midrib or on the veins and these openings are called as hydatodes. These openings are called as what? Hydatodes. Guys, remember this is previously they asked that there is a loss of water from the herbaceous plants early in the morning or late in the night. It happens through, it is called what? Hydatodes. What are these hydatodes? We find a minute pores, either you find on the midrib or on the veins. Through this minute pores there is a loss of water. So, sometimes the water is oozing out from this and this water accumulates in the morning or in the night on the surface of the leaf. And remember, not in all the plants, but remember in case of herbaceous plants. So, the minute pores through which there is a loss of water. What you can write here? The in guttation or in root pressure, what you can write? The loss of water through minute pores. Through minute pores. These minute pores are itself in brackets you can write, they are called hydatodes. In herbaceous plants, itself is called as guttation. And remember, experimentally it is studied, it happens with the help of what is called root pressure. So, what is the definition we have written? Loss of water from uninjured parts of the plants of herbaceous where you find minute pores, and these minute pores are itself they are referred as what? Hydatodes. Very, very important, right? So, what your final conclusion? Water comes out of the leaf early in the morning, late in the night, not only through stomata and also through hydatodes. Very, very important. This is one thing you try to remember. Then apart from this, now if you take examples, for different examples you can study for imbibition. Now for imbibition, generally it can be discussed in terms of matrix potential. Okay. So here when we talk about imbibition, it will be discussed in terms of a matrix potential. Matrix potential in the sense we say, so when you talk about matrix potential, what is that? Potentials we studied, water potential, solute potential, pressure potentials. We studied all these three, right? Coming to matrix potential, we say psi m. Psi m is nothing but ability of the compound to absorb. So it depends upon absorption, but you can write down it depends upon the concept called as a surface adsorption. It depends upon the concept called as what? Surface adsorption. So, if you take the wood, for example, if you take the wood, or if you take even what is called seeds, right, splitting of the early historic man, a seed germination, and all the examples whatever we study, there we find, of course we find water potential difference, no doubt we find what is called water potential difference. Water potential difference, but that water potential difference, or here we say the imbibing pressure itself is referred as matrix potential. The pressure exerted by the imbiband, itself is referred as what? Matrix potential. We can take the value as psi m. Okay. So, but even remember, imbibition is also water potential difference between affinity between the imbibant and adsorbent, and water potential difference is also very much essential to happen imbibition. That is nothing but what we call surface adsorption. So, here the note point is highest matrix potential we find, or we say highest matrix potential is recorded for, that is psi m, it is recorded for xanthium. So, the xanthium has the highest matrix potential. What is that? Minus 2000 megapascals. Very, very important. What is that? How much is the value? Minus 2000 megapascals. And this minus 2000 megapascals, it is for xanthium. And try to remember, xanthium is a short day plant. Xanthium itself is nothing but what? A short day plant. So, when you look at here, the matrix potential imbibition, in that what is the pressure exerted is on the surface of adsorbent, it is called matrix potential. Wood and seed, you can take examples. Water potential difference is must and compulsory, and highest matrix potential we find in case of xanthium minus 2000 megapascals, and itself is referred as a short day plant.